Here's sample test problem number 3. The system consists of 4 particles located as shown. The 4 particles are connected by massless rods. The system rotates clockwise about the origin with a kinetic energy of 5 joules. Find the location of the center of mass of the system. Well, the x center of mass of the system is going to be equal to the summation of every mass multiplied by its x position over the total mass of the system. In this case, it'd be mass 1 x1 plus mass 2 x2 plus mass 3 x3 plus mass 4 x4 divided by mass 1 plus mass 2 plus mass 3 plus mass 4. So this would be 3 kilograms times a negative 2 meters plus 2 kilograms times 0x for the x position plus 1 kilogram times 2 meters plus 2 kilograms times 0 all over 3 plus 2 plus 1 plus 2. So that is equal to negative 6 plus 2 is a negative 4 over 8, or a negative 1/2 centimeters is the x location of the center of mass. If we do the y location of the center of mass, do the same sort of thing. Summation of every mass multiplied by its y position over the total mass of the system. And in this case, that's going to be mass 1, which is 3 kilograms times a y position of 0, plus mass 2, which is 2 kilograms, y position of a negative 2, plus 1 kilogram times 0, plus 2 kilograms times 2, all over 3 plus 2 plus 1 plus 2, which is going to be 0 over 8, or 0. And finally, our z center of mass is going to be, all the locations are 0, so that's just going to be 0. So there is our center of mass location for this system. We want to find the moment of inertia about the rotation axis. Moment of inertia is the summation of every mass multiplied by its distance from the axis squared. And so in this case, we have m1 r1 squared plus m2 r2 squared plus m3 r3 squared plus m4 r4 squared. If I can fit all that in there. So this is equal to 3 times 2 squared plus 2 times 1 squared plus 1 times 2 squared plus 2 times 1 squared. So that's going to be 3 times 4, 12, plus 2 plus 4 plus 2, which would be 20 kilogram meter squared. That is the moment of inertia about the rotation axis for this system. We want to find the angular velocity omega. We're given the kinetic energy, which would be 1/2 the moment of inertia times the angular velocity squared. So the angular velocity is going to be 2 times the kinetic energy divided by the moment of inertia square root, which in this case would be 2 times 5 joules divided by 20 kilogram meters per second squared, and that is equal to 0.707 radians per second. So that is the angular velocity of rotation of the system, 0.707 radians per second.